Okay, welcome to Trigonometry. We're going to start with some very basics. The Pythagorean Theorem and SohCahToa. These are your two real introductory theorems in trigonometry. You could rebuild everything in trigonometry just from knowing these two things, Pythagorean Theorem and SohCahToa. So, you've probably seen these before. The Pythagorean Theorem says a squared plus b squared equals c squared. And what you do when you're looking at a triangle, let's say we've got some numbers in here. I'm just going to make some stuff up here. Let's say the hypotenuse was 10, and let's say this side over here is 7. What is A? Well, what you would do in this example is you would substitute in the numbers you know, and don't do anything to the one you don't know, that A squared. That's just going to stay there. So A squared plus 7 squared equals 10 squared, and then you just follow through the algebra, and you'll solve it. 49... 100, this is where it's good to know your multiplication tables. And what you get in the end is A equals the square root of 51. So it's very common when you're doing triangles, particularly right triangles, to have these square roots in them because it's a natural consequence of Pythagorean's theorem. You're going to be taking the square root of things. So that's that part. Now, SohCahToa is also extremely important. And what I've written here are some basic rules defining three functions. Okay, here are your three functions, your trig functions for SohCahToa: sine, cosine, and tangent. And I want to just make a very clear point here. What I am not saying, right, this is not saying sine times that angle. That's not it. This is sine of an angle. Much like we would say f of x, right? When we say f of x, it's not f times x. It's a function of x. And these trig functions work in the same way as we're used to with f. So we think sine of an angle, cosine of an angle, and so on. Now what this part means over here, this tells you the ratio of legs of the triangle to do. Well, not always legs, sometimes it's the hypotenuse too. So we'll just start with this example right here. Let's start with that and say, what is the sine of b, right? This angle b right here. So I think to myself, okay, what is opposite b? Okay, so opposite is as far away as you can get. That's the opposite over there. So I would say sine of b equals AC. Okay, right? AC is that line that goes between points A and C. And the hypotenuse is AB. So we would say sine of b equals the ratio of this side over the hypotenuse. And likewise, cosine of b would be the adjacent side, that's BC, over AB, and tangent of b equals opposite, that's AC, over adjacent, that's BC. Okay? So sometimes you'll see the sides of a triangle labeled in particular, like they'll have letters on them, the way it does up here, right, with this A, 10, and 7. Sometimes it will just have no labels on the sides, but there will be labels on the vertices of the triangle, and you are expected to create these kind of, they're kind of like side lengths, A to C. So you just take this idea defined here, and you apply it to whatever picture you're given. Now there are three more trig functions that I want to go over, and this will be the last part. Cosecant of an angle is just 1 over sine of an angle. And it's not 1 over sine times the angle. It's 1 divided by sine of the angle. Okay, cosecant is just the inverse operation of sine. And I actually should rephrase that. It's the reciprocal operation, okay? It's 1 divided by. Secant is 1 divided by cosine. And cotangent is 1 divided by tangent. Now, I personally have a very easy time remembering cotangent because it sounds like tangent. But with these guys, secant and cosecant, people get them mixed up all the time. You just have to remember, it's like the S and the C switched, right? C goes to S. Whatever dumb trick you can come up with to remember this, that's fine with me. Just don't get them mixed up. Secant does not go to sine, and cosecant doesn't go to cosine. It's the other way around.